let's go ahead and get started. Jason, after my spiritual thought, could I have you say the opening prayer for us today? Thank you. All right, so my wife actually sent this to me earlier today, something that she wanted to talk about with me, and I wanted to share it with you guys. So this is from Preach My Gospel, but I feel like it relates really well to us both as students and as programmers. So none of us should be like the fisherman who thinks he has been fishing all day, when in reality he has spent most of his time getting to and from the water, eating lunch, and fussing with his equipment. Fishing success is related to how long you have your line on the water, not to how long you are away from the apartment. Some fishermen are away from home for 12 hours and have their line in the water for 10 hours. Other fishermen are away from home for 12 hours and have their line in the water for only 2 hours. This last type may wonder why they do not have the same success as the others. The same principle applies to us. Just in thinking about that and evaluating how much time we have our lines in the water. It's so interesting because as programmers, the majority of our time is spent on a computer, okay? And more professions are becoming like this, where more and more work is able to be done over a computer and using a computer. And with that, it's really nice because you can do a lot with a computer, but it can also be really hard because of how much you can do with your computer. You know, on the same computer that you manage all your bank stuff, you also write all your code for your programs, you do your religion class, you play games, you do all your Facebook and social media and stuff. Like it's an endless list of things that you can do with your computer. And I remember when I was when I was doing my master's degree, time just seemed so precious and so fleeting. And I ended up, making rules for myself. I'd have to wake up really, really early in the morning to get my work done because I was also working full time. And so as you think about your habits, your daily routines, your schoolwork, your church service, your scripture studies, and everything that is trying to get your time, just think about that and how you stay focused with your time. So that's my thought today. Jason, go ahead.
Dear Heavenly Father, we are so very grateful to be able to meet together today for class, that we might be able to learn more about the language of Python and how to better use it. Father, please bless that as we learn throughout this class, that we might have Thy Spirit with us, that He might help these things come quicker into our minds. Father, please help us throughout the week also, that we might be able to get our assignments done and that we might be able to be successful. Father, we love Thee and we thank Thee, and we say these things in the name of Thy Son, Jesus Christ. Amen.
Amen. Thank you, Jason. All right. Well, today we're going to do something a little bit different. I do have some slides that I wanted to go through with you all today. But first, before we go into that, I'm going to send us out into breakout rooms. I'm going to have about 3 people in each breakout room. You're all going to share your code that you submitted on Saturday for your proof assignment from last week. And you're just going to share 2 things with everyone. What was one thing that you learned, and what was one thing that you enjoyed? Okay. And if there was nothing that you enjoyed, then you could just say that you enjoyed submitting the assignment and moving on with your life. Okay. So everyone share your screens. One thing that you learned, and then one thing that you enjoyed. And if you have questions for each other, please ask. We'll come back in about 15 minutes. Any questions? Okay, see you guys in a few minutes. Okay, so first here in the video spreadsheet, if you ever have questions about how to start an assignment or what the assignment is asking, these introductions columns are all for that. Some of them I'll write some code, some of it I'll just have a bunch of comments to say what I'm planning to do when I code it. But all of these introductions videos should help you if you're not sure how to get started with an assignment. Then all of these walkthrough columns are me showing my completed code. On some of the smaller assignments, I'll actually code it out and you can see my thought process there. On some of the larger assignments, I'll just kind of show my completed copy and you guys can look at it, okay? This is part of the reason why we have the late policy in the course, is just because if you could submit everything late for full credit, then you could do all the work and from my stuff and not do any of the work and get any in this class. Okay, so all of this is here for you. If you needed help with your week 5 prove and you couldn't figure it out, watch this video. I'll go through the code in here and you can look at it and be like, how on earth did that happen? I don't know how to do this. That's why these are here, okay? And even if you submit it a couple of days late and get 40 or 60%, it's better than just not submitting it at all. So these are here for you. Please be aware of them. With that said, I am going to look at this just real quick with you right now so that you guys can see how I implemented my week 5. There are lots of different ways to do this. Some of this code you got from the download. The main thing that I was getting questions on while going to your different rooms was this draw scene. Okay, notice right here, I'm calling draw sky, draw ground, draw cloud, and draw grass. We'll look at each one of these. So draw sky, we have our canvas, and then we set up these coordinates where we're going to start and then how big we're going to make it. Okay, so I'm saying I'm starting at 0 and 0 for coordinates, and we're going to go to 799 and 599. And someone asked me, I can't remember who asked me, but they're like, hey, do you have any like tips on how to work with this, this location system in Python? And my answer was no, it just takes practice. You can see what all these parameters are, to create a rectangle, but it just takes practice learning how this works. And even with practice, I'm always like doing trial and error anyways, just running it. I'll change one of these numbers and see, okay, did that move it to the left or the right? Did it move it up or down? To kind of get a feel for what each one of these parameters is doing. Draw ground, another rectangle. Draw cloud. So this one, we're passing in our canvas, our cloud groups, and clouds per group. So if we look here, where was that declared? Draw cloud. So we're saying that I wanted 5 clouds, and then 50, if we look down here, it's clouds per group. So the number of ovals that I'm going to make for each cloud. All right. A little bit of error checking right here. Then I say I'm going to try to get a good range to put these clouds in so that we can actually see them on our canvas. And then we're going to say, until we get to 5 clouds, here's what we're going to do. We get a random location, making sure that it's in our right range. And then let's see here, once we get further down, I'm trying to find the line of code that actually draws it. So all of this is just to get our location, and then add the new XY pair to the checking list. And then finally, once we have everything set the way that we want it, we'll go ahead and create our oval with everything passed in. Okay. Then we did something really similar with the blades of grass, except it was a lot easier because a blade of grass is just one thing and not a cluster of shapes, all that have to be stuck together like a cloud is. Okay. And so for this one, I said that I wanted 2,250 blades of grass and where I wanted them to be. And then for each one, I just created a rectangle that said that we're going to pull them from X1 and Y1, and then how big, how wide, and how long they're going to be for each one. Okay, so that is here for you. Any questions on this, you guys? Okay, well then, let's see here. We got about a half an hour to go into functions. So during this lesson, you will learn about learn additional details about writing and calling functions. These will help you understand functions better and use them more effectively. They include variable scope, default parameter values, optional arguments, and the way arguments are passed to functions. So some of this will be a review for a lot of you guys, and some of it will be new. So intro to scope. We've talked a little bit about scope, but when you start working with functions, scope really comes into play. All right, originally, when you're just running all of your code just top to bottom, you declare a variable and it's accessible, okay? And that it's just simple as that. When you start working with functions, if you declare a variable inside of a function, it's not accessible outside of the function. So if you need to use data inside of a function that's from outside of a function, you have to figure out how you're going to get that data into the function because it's in a different scope than its parent scope that is outside of the function. So looking at this, the scope of a variable determines how long that variable exists and where it can be used. There are two categories of scope in Python. They're local and global. A variable has local scope when it's defined inside of a function, and a global variable is when it's defined outside of all functions. So looking at this right here, we have two variables that are declared in here. On line 3, we declared g with the value of 25. And on line 8, x is equal to 1. Okay, x is inside the function main, making it a local variable that is accessible inside of the main function. G is declared outside of all functions. It's not inside of a function, which means it's a global variable. All right. Has anyone ever worked with global variables before? So what are some good things and bad things about global variables? What do you guys think?
A nice thing is you can use it wherever you want to. So like in your program where you had that list of hexadecimal digits, you could use that anywhere you needed to, whenever you needed to generate a hexadecimal code.
Yeah, great. Very observant. Awesome. Okay, so that's one of the pros. Let's go back to my code real quick. This guy right here, declared outside of all functions, making it a global variable. If I tried to access root outside of main, it doesn't exist. It's not accessible. Hex, however, is accessible everywhere because it was declared globally. So that's nice. Okay, so that's one perk of having global variables. Any other good things about having global variables? Okay, any bad things about having global variables? What's wrong with them? Go ahead, Preston.
One thing I notice when I use global variables is, at least in big projects, is I run out of variable names. And another thing is sometimes if you use them in a function, you might accidentally change them, and then it changes it for the other function that's trying to use the same global variable, and it really just messes a lot of things up. So it makes your coding quite a bit more complicated if you can't keep track of it.
Wow, that's a really good point. Two really good points. So I'm going to tell you guys a story. I started working at this one job. It was with a church, and the project that I was put on was it was a great project. It was built on a really good technical stack. Back in the day, they were using AngularJS as the front end web framework. We're using .NET for the back end and an Oracle database. Okay, we were making a website for employees to be able to, update direct deposit information, emergency contacts, contact information, all of like data pertinent to the employee when they worked at a company. But the thing was, this project had global variables everywhere. And it was because the developer who had started work on this project had never touched Angular before. And so when they would declare variables, they didn't want to put forth the effort to code their program in such a way that it would be modular. They wanted everything in one place because in their minds, it would be faster to implement that way than if they created all these files to keep things in separate places and all these functions. Instead, they'd have a function that would be like thousands of lines long, which was awful, okay? But here's what happened in that application. Months and months go by of this application being built, okay? Now, that is a lot of money right there. No matter what company you work for, if you are paying a senior full stack developer, you're well into the 6 digits, pretty much no matter where you're working, okay? And months of that go by, that's a lot of money just paying one person, but there's also a team of developers working on this, okay? And what ended up happening was after about 5 months into this project, it became just broken. everywhere was just broken. And there were these crazy anomalies and things were just awful. And, you know, someone would go to like update an emergency contact phone number and it would update some other random emergency contact's address and like really, really random things. And it was really hard for everyone to be like, why is this happening? This is like the worst piece of software everywhere, anywhere. And the answer was global variables. That was it. That was like I mean, there was probably other things wrong with the application, but what was causing the bugs were just global variables. And that was it. Because when you have a global variable, yes, it's nice because it's accessible everywhere, but it's also really bad because it's accessible everywhere. You know, when you're writing code, no matter what language it's in, you want your code to be concise and clean. All right. If I have an application with a million lines of code and the only variables that are declared are global variables, then it will be impossible to keep it clean. Like Preston was saying, you know, I will update those on accident. And then when I go to use them, they'll be updated somewhere else when really I wanted just a copy of a piece of data or something like that. I'll run out of names. I'll try to use the name for one thing that I already used somewhere else. And then I just like redeclared a variable that was already there and I just changed it everywhere. Okay. So global variables are really, really, really bad in general. And so with that said, anytime you're working in a professional environment, you know, if you see them, it's just bad news. But the majority of the time, if a company knows what they're doing and if a project team knows what they're doing, then they will likely disallow the use of global variables, especially like in web applications. You just won't even have any of them because of how dangerous it is. And so global variables, it's like, oh yeah, it's really nice. I can declare this on line 3 and then I can use it anywhere in my entire application. Well, let's say you're working on an application where you're like teaching the user how to do math or something like that. And you have all these different like formulas for like computing area and circumference and perimeter and volume and all these different things. And all of a sudden you have like area, the variable named area is a global variable. And it's like the same area as the area of a circle and the area of a rectangle and the area of these 5 other shapes, you know. But if I declare area inside of the function called compute square area, then that area will be just fine and it will be in that local scope. And then I can have another function to compute the area of a circle. And I can use the variable area in there too. And there are 2 completely different variables in their own scope that will not ever conflict with each other. And so a lot of programmers will get into this mindset of using global variables because they think it will save them time. But the more time you spend in an application with global variables, the more time you'll end up wasting tracking down bugs because of the global variables. So just be aware of that as we talk about global variables and scope. The tricky thing is though, the reason why programmers think that it'll save them time is because then it's accessible everywhere. So if you don't make global variables, then you have to figure out how you're going to use parameters and arguments and other methods to say, okay, I need this piece of data in a completely different place in my application. How do I get it there? And depending on what language you're programming in, that will change how you can do that. But there's always a way to do it. And that is why we have to learn about scope. So find the local and global variables. Okay, so go ahead and just put in the chat or turn on your mic. Which one is the local variable or variables, and which one is the global variable or variables?
In shapes is the global variable.
Yes, great. N shapes is the global variable. All right, what are our local variables? Preston, yeah. So local variables are all area, length, and width. Now, if in my function square area declared on line 3, if I tried to use width in here, what would happen?
Sorry, what was the question again?
If I was going to use the variable width on line 4, what would happen?
Oh, it wouldn't work because it's a local variable.
Yeah. Okay. So, and we can look at this. If I pull up my text editor here, and I'm just going to make I'm going to make a new file here, and I'll just call this temp.py. And I have a function called, we'll say, compute area. And then in here, we'll say width equals 20. Whoops. Okay. And then right here, I'll just say print width. All right. Width is declared inside of my function called compute area. You can see my text editor already doesn't like a couple things. One, it says I'm not using width. It says this is an unused variable. Even though 2 lines later, I say print width, it recognizes that this width right here is a local variable that's not getting used. And then right here on line 4, it's like undefined variable width. This isn't declared, even though it looks like it is. So let's try a couple of things. First of all, I'm going to run this just the way it is. So I'm going to right click on this, open an integrated terminal. I'm going to say py temp.py, and you can see we get an error, a name error. Name width is not defined. Okay, now let's try one other thing. If I declare width up here and I say width equals 5, and I hit save. Okay, let's call this function just for kicks. I'm going to call compute area. What is your guys' prediction? When we print width right here, will it print 5 or 20? I see a couple of 5s. Anyone think 20? Let's try this. Okay, so I just saved it. I come over here, up arrow, and enter. Yeah, so it is 5. So look how confusing this can be. I have 2 variables that are named the exact same thing, but because of scope, they're in different places. Now, this is particularly confusing because one's a global variable and one's a local variable. If I hadn't said that right here, then I could use my width variable inside of here, inside of compute area. But because I'm declaring this as a new variable and assigning it a new value, it's creating a different variable in that local scope. All right. And so it can get really messy merging global variables with local variables, which is why we tend to try to avoid it. So, all right, let's keep going.
I have a question.
Oh yeah, go ahead.
So in that kind of a situation, how would you access your global width variable instead of just redeclaring a new local width variable?
Yeah, so in Python, there are a couple of ways to deal with that in Python. Okay, one of them, there are ways to copy and functions that will directly access those global variables. And so if I wanted to make a new variable from a piece of data, memory types, well, the way that memory works in Python is when I make a new variable, it will create a new instance of that variable with its own space in memory. Okay, but then if I want to make a copy of that variable very frequently, when I declare a new variable with that same value of another variable, it will actually point to that same place in memory. And so when I'm working with this global variable, I would just have to use some of the Python built-in functions to say, hey, I'm specifying this as my global variable. You know, you can get the address of a variable and say, hey, this is the variable that I want to modify. It's just messy. So that's a great question. Thanks, Preston. Okay, any other questions, you guys, before we keep going? Okay, well, let's keep going. All right, scope practice. What's our question here? What is the output? If you look at this problem, what's our output here?
Would it just be the area of the circle?
Okay, someone thinks error, someone thinks area. Anything else? Okay, let's try this. So if we were to run this, look at this error that comes up. So first, main gets called on line 12. Okay, so 12 is the first line that actually gets executed. We come up into the function main, line 4, it says input, enter the radius of a circle. Right here, I entered 2, and then we got an error. Okay, and let's look at this. So line 15, if we look, wait, hang on. We can't even see line 15. Oh, whoops. Okay, so line 5 in main area, we call circle area. Okay, and then down here on line 12, saying from here, we're saying area equals math.pi times radius. And then the name radius is not defined. So radius was declared in the scope of main on line 4. And then in line 8, I obviously need my radius to compute my circle area. And so on line 9, it's like, hey, I actually have no idea what radius is. It's not declared in the scope of circle area. And so this gave us an error, and we weren't able to return anything or print anything. If I was going to make this code work, what would I have to do?
I think the easiest way to do it would be to add radius as a parameter in circle area and then pass it as an argument in your main function.
Yes, yeah. So right here, if we come back to our code over here and we look at our week 5 proof, all right, there are a number of functions that I have that have a bunch of arguments, pieces of data that I have to pass in from a different location in code that I'm going to have to use inside of a function. So if I want a function called, what was this? Circle area, all right, or compute circle area. If I was going to write a function for this, then the one piece of data that I would need is the radius that I would need inside of circle area. Same thing, if I was like, oh, I want to like compute the volume of a cube, well, I just need one dimension of that cube to get the volume, okay? But I need that one dimension. Same thing with the circle area, I need that radius. And so once the user inputs a radius, then I would just put that variable right into here to call circle area. And then down here, I could call it anything I want. I might as well call it radius because that's what's being used as a variable name. But we would just have that as a parameter inside of circle area, and then we could use it and we wouldn't have any errors. Great job, guys. All right, default parameters. We looked at this a little bit last week. Python allows function parameters to have default values. If a parameter has one, then its corresponding argument is optional. If a function is called without an argument, the corresponding parameter gets its default value. So right here, main is being called on line 13. And then on line 4, we call the function arcLength with 25 being passed in. Notice that on line 7, we have 2 parameters. We have degrees and radius. We also have equals 1. This is how we declare a default parameter. So if I had on line 4, 25 comma 16 or anything, then radius would get that value of 16. Where I don't pass in 2 values, I only have 25, radius will just get whatever the default is, which is specified right here, equals 1. Okay. All right, let's keep going. In Python, there are many data types, which we've already talked about. Not all of them behave the same way when being passed from different locations or performing operations. In Python, variables are processed differently based on their data type. Any thoughts as to why this would be? Why would we care what the data type is when we're working with them? Why would Python care? Jason, I can't hear you. It doesn't look like you're muted, but I can't hear you. Yeah, I still can't hear you. No worries. Yeah, go ahead, Preston.
I think we might have talked about this earlier. Is it because the complex data types are passed by reference, but the basic ones are passed by value?
That's exactly why. So let's think about it. We're not going to get too much into how computers store data in this class, but suffice it to say that if I have the number 5 and I save the number 5 in my computer, that takes up a lot less memory than if I was going to save a paragraph string in my computer. Should make sense, okay? The longer a string is, the more data it'll take up. The longer an array or a list or a dictionary or a tuple is, the more space and memory it will take up. And as those data entities get larger, if I'm going to pass around those huge chunks of data all over the place, it will make my program be really, really slow. All right. And so Python by default, if it has like a number that's being passed, it'll go ahead and just pass that number because it's a really small piece of data. Okay, it's just a number. But if it has like dictionaries or lists or something like that, it will pass the reference. It will pass an address of that location so that instead of sending all this data, it just sends one piece of data, and wherever that's needed, it can access it by that address in memory. So when a computer executes a Python statement to assign the value of a Boolean, integer, or float, the computer copies the value of one variable into the other. It just makes a straight up copy because Booleans, integers, and floats are pretty small. When a computer executes a Python statement to assign the value of a list, set, or dictionary variable to another variable, the computer doesn't copy the value, but instead copies the reference so that both variables refer to the same value in memory. Okay, again, this is to help with performance, to help make sure that we don't end up with too much data stored that we don't need, and to help things go to perform as quickly as possible. All right, so integer versus list. Here's an example of declaring some integers. Lines 2 and 3, we say x equals 3, y equals x. Let's see here. I wonder if I have this saved. Okay, I don't think I have this one saved. Okay, but right here, x will have the value of 3, and then y will also have the value of 3. This will not reference x's location in memory at all because 3 is a small data type. It's a number, and it's a small piece of data. And so y, we could basically just say on line 3, y equals 3 as well. That would essentially do the exact same thing. They'll both get the value of 3, and they'll both be stored in different locations in memory. If I change y by saying y plus equals 1, then it will change y and it will not change x. They're separate variables stored in separate locations in memory, completely independent of one another. Let's look at a list. Okay, right here, if I declare lx as 7 and negative 2, and then I declare ly as what lx has. Okay, notice that if I append 5 to ly, look what happens on this print. Okay, before changing it, they were both 7, negative 2. And after changing it, they were both 7, negative 2, 5. They had 5 appended to both. And that's because when you assign a list to another list, even if you're declaring a new one, because Python doesn't want to make that copy and bog down its resources and hinder performance, it will just store that location in memory. So if I was going to look at what ly really is, it's a location in memory. It's accessing lx's location in memory. So if I changed one of them, it'll change both of them like we're seeing here. So with that said, there are some ways that if I wanted to change ly without changing lx, I could. And so we would use something like this. Okay, built into Python, I have a list and I say, hey, I don't want to copy the reference or the address of this list. I want a duplicate of the list itself. And so if I did this, I say lx equals 7, negative 2, and ly equals lx.copy, then that would be the exact same thing as if I, did that. It'll just make a direct copy of it. But for me to do that, I have to use the copy function. Otherwise, by default, it won't allocate that separate space in memory. It'll be like, hey, this is a list. I don't want to have to copy this data. Just here's a place with that list that you want. But if I need to have it changed, if I wanted to append 5 to one of them and not the other one, then I'd have to use that list.copy to do that. Okay. So let's go ahead and look at this run and let's see what happens. Py list. All right, let's take a good look at this real quick. Okay, right here, our first print, before changing ly, we have lx is 7 and negative 2, and then ly is 7 and negative 2. Notice this right here. ID is a function in Python, and you can use it on any data type if you want to see the address of something in memory. So this is how your computer finds stuff in memory. Just a big old number, seemingly random. But this is the address of X on my computer right now. This time it ran. And this is the address of Y. Notice that because I used copy, these addresses are different. Now, let's try this one more time. We'll look at the rest of this here in a sec. If I take off that dot copy, that function copy, and I run this, okay, notice that these addresses are exactly the same. Because by default, it's not going to duplicate that list and store it in a different place in memory. It's going to say, okay, we have a list. It's a big set of data, even though there's only 2 values in it. We're going to go ahead and just point you to the right direction of this exact same list that you have somewhere in memory already, so that we can perform better. Okay, so by default, it will do this, and ly will just have basically an address to that location in memory. But we can use .copy, and when we run it, it'll have 2 different locations in memory. And then if I say ly.append 5, then it will only append to ly, because they are now a separate location in memory. Okay. Any questions on this?
Yeah, Brother Birch, I have a question.
Yeah, go ahead, Jordan.
So let's say that LX is in a different class, then how would you call that to LY?
If it's in a different class.
Yeah. Would you still be able to, sorry.
No, go ahead. You're good.
Would you still be able to put like lx.copy, or would you have to put something else?
No, as long as the variable itself is accessible, then you could use lx.copy.
Okay.
Yeah. The same as you could, like if it was in the same function like it is now, as long as it's available to you in that separate class, then you can use lx.copy and it'll copy it the way that you would expect.
And same thing if it's in a different function, just lx.copy.
Yep. Yeah, great question.
Thank you.
Yeah. Okay, any other questions? Okay, well, you guys, this is all I had for you today. Surprised we're ending 5 minutes early. Usually we're like 2 minutes over. So, but this has been awesome. I hope that this has been helpful for you.
Did you guys get
I'm going to stick around for a couple minutes if anyone has questions.
I got wrong? One.